All right, excellent. Well, again, thank you, Magda. My name is John Paul Giancarlo. I'm technical sales specialist for Autodesk. And today I just want to talk a little bit about Arnold 6 and how do we increase efficiency with Arnold, specifically GPU and other means. Before I continue, I would like to share this safe harbor statement. So any of the purchasing decisions should be made upon these statements that I'm about to say. So a little bit of an update, but before we start, I would like to talk a little bit about Arnold. So for the people who doesn't know what Arnold is, it's a path tracing pioneer. So it was designed for production. It works very well with very large scenes, so the larger the better. And it addresses very complex rendering challenges. And that means having different type of shading techniques working together seamlessly in a scene. It's very comprehensive in C++. They have a very good Python API. It's compatible with CPU and GPU, as you should know by now. It ships with Maya and Max, and it's integrated in the main DCC applications. In the past, Arnold was focused or was used mainly in the film industry and TV industry, as you may see here. Image Engine used Arnold for Game of Thrones Season 8, DigiPictures on Love, Death and Robots, even a SpongeBob movie, even Micros, who basically use Arnold in a different fashion. So they were using Arnold to render cartoony type of shading. The mill also, in conjunction with Houdini, they use the operator framework in order to give life to these robots on this particular nice song of the Chemical Brothers. Man versus Machine was again another very complex scene where they have to render trees and trees of fibers, and that's where Arnold was the hero. So you can render these type of very complex scenes very quickly and nicely with Arnold. So it's also used for cartoony effects, especially in the Japanese market. There was a lot of demand, so the team made a toon shader, which works very nicely. But it didn't stop just there. Companies like Volkswagen has been using it for visualization of the cars, and inside of the cars, you might see they're using the contours of the outlines to show basically the blueprints of the car, etc. Here you have another example of how that shader can be used. But it doesn't really stop there. So Arnold evolved to a point where even the different industries, for example, started to use it. So manufacturing in this case, so Nike is using Arnold to render very complex fibers, subsurface scattering, as you might see over here, in order to give their renders a little bit more realistic look. But it's also been used in things like civil engineering, simulations, this type. So it didn't stop just there. So Arnold's been evolving to a point where it's been used across all industries. Now, talking about the release base, because people's asking, hey, why are those release base different? So we have different components. We have Arnold Core, which is a standalone version of Arnold. We have M2A, which is Maya, Max. We have Houdini, Cinema 4D, and Katana. And you will see there's a number of releases there, and that's because we're addressing bugs and the team is addressing problems on a constant basis, and regularly. Nowadays, we are releasing every month at least one point version. So the Arnold improvement, these are the little things that really matter in production. This is the one that I wanted to talk about because we don't have that much time, and I'm going to go through the whole spectrum of what you can do with Arnold. But things that are important now is what we've done. So we made things like the lens distortion compatible now with 3ds Max. It is important in the Polish market because I know 3ds Max is being used wisely in Poland. As you might see, we have the 3ds Max inverse cubic and the classic cubic working there. Lens tilt and shift also now compatible with 3ds Max. This is another thing that we added. Microfacet multiple scattering is also there for single scatter and multiple scatter, as you may see there. See the difference, how brighter that image can get. Like I said, little things that really matter. So microfacet multi-scattering for Dielectrics was another thing that was important. So conserving the energy was really important for us. So now we've achieved that in the latest version of Arnold. We can see it for multi-scatter, again, different examples here. How you can see on the top, things are, the energy is not conserved, while in the image below, the energy gets conserved. So now we have another thing that is, this is a little bit of a sneak peek. You will see in the next release of Arnold. It's the nested dielectrics. You can see a much nicer natural look when you have different objects with different refractions, indices even. Like, for example, you have ice and you have glass and you have water or a liquid. We have different types of indices of refraction. Those nested dielectrics give you a much natural look. You might see here on the left and the right that an image that's much more pleasing to the eye. These different examples also for different type of liquids. So we have here what we call kind of a liquor, could be rum, could be cognac, even, I don't know, orange juice, and then this is supposed to be like an old Coca-Cola, I guess. We also introduced different type of shaders which are Boolean operations with the clip geo shader. The clip geo shader just gives you the ability to use geometries in order to clip or do Boolean operations after the fact, so during rendering times. This is quite useful for different applications, as you might see. In the automotive industry, for example, you can see it's being used a lot, or it's very of an interest for people. The medicine field as well can be used to show or to reveal different layers of an object as well. So what you can do with this is you can basically select what you want to clip or what you want to apply the Boolean operation to. You can basically have the ability, to do so. It's also being used for artistic purposes, as you may see here with the Nike shoe, which is quite a nice effect you might achieve just by using this shader. Another thing that was important was that to make sure that whenever you work with Bifrost, you could see any of the Bifrost procedural directly with Arnold without any issues. So now we have ability to work with Bifrost procedural, right, straight out of Bifrost without having to cache even. So this is a really nice feature that will help you basically work and iterate a lot faster. So when it comes to performance improvements, I just wanted to talk a little bit about what is done. So what's really relevant. So we have a 6 times faster interactive rendering, specifically on Linux, on the GPU, 2.1 faster procedural initialization, and that's thanks to a lot of things that we'll discuss in a bit. So we have progressive renderings being sped up by 24%, and it's consuming 30 times less memory. So it's got a better numerical precision for faraway objects. I'm going one by one because this is important. If you can read faster than me, it's good. 3 times faster curve generation in Alembic. This is quite important. Reduce adaptive sampling and overhead. Multi-threaded crease division. Faster procedural update on GPU. And the time to first pixel has been reduced by 20% on the GPU. So 2 times faster GPU cache. And 50% reduction in BVH memory used by geometry on the GPU. When it comes to bug fixes, there's over 272 fixes that we fixed on the latest version, specifically addressing other things that the CPU or any things inside of Arnold, but we also put a lot of attention to GPU, a lot of attention on the USD developments. Alembic is very important, OSL and Material X. So now a little bit of an update on the GPU. As you guys might know, in the past, we started with Arnold 5.3 with the beta. We have a few things. It could be used as a beta, just to test certain things, for example, shading networks, atmospheric instancing, procedurals, etc. That we start moving a lot faster. You can see now in Arnold 6, we made it a production-ready render, and now we support a lot of things. So the main things, and we have a very good ratio of coverage at the moment. And what is important to mention is this Arnold, why is it live device switching? And the only reason this is a live device switching is because anything that you do on the CPU is going to be translated into something that optics can understand. So the GPU, the hardware can understand. So you don't have to change the way you work. You can do your regular workflow without any issues and just choose whatever you want to use. If is it a GPU or a CPU, it doesn't really matter. You should get the same result. That's true, and Maya and all the other software, so we have implemented it into Maya, and it's working quite nicely inside of Maya. Same story with 3ds Max, Houdini, Cinema 4D. What it's been doing, or what the team's been doing in order to accelerate the process of the GPU is adding certain techniques. One of them is the on-demand texture loading, which I think we mentioned yesterday during the Q&A or Ask the Expert session. And that basically reduces the time to the very first pixel. How does this work? Is basically, you're going to tell Arnold, so Arnold's going to tell to be, okay, you don't need to load in RAM any textures that are not be shown on the screen. So that's one of the things, and we've managed to reduce a very first time to pixel from 1 minute even to like 5 seconds in certain examples. So this is quite important. This is going to improve on every version of Arnold. So what's another advantage is the peak GPU RAM. So we now consume a lot less RAM than before due to the same technique or the same thing that I just explained before. This is a little bit of an example of how you will see the GPU working on a regular file. So this is just a face basically with software scattering. I mean, it's typical render on the GPU. You can see you can iterate very fast. And it's quite nice to work with. So it's much faster to work with the GPU when you're doing your look development than the CPU in most of the cases. But not just that, because we've improved a lot on the performance and the GPU now, you're able or capable of doing a lot of very complex rendering, like this in particular, which have trillions and trillions of curves being rendered with the GPU. These are very complex examples. This one in particular in Houdini, as you may see. But we also have like look dev or product design example here in Cinema 4D, where you see chat, for example, Ashley shown and seeing pretty quickly what type of result he's going to get using the GPU. So the GPU improvements, what I think are relevant to talk about, especially Arnold 6.0.2, as the texture attribute tags. They have new cameras, UV camera, remap, filter maps. You can have a merge shader now. You have OSL transforms, so open shading language transforms. Shadow matte shaders. You have a minimum pixel for the curves and points. You have an optics denoiser now working for all the AUVs or arbitrary output variables. We now have the ability to choose the bucket scanning order. So if you want to go in a spiral, we're going to go random. Now you can do that. Light filter support, which I think was quite important. So you would have a light decay, light blockers, for example, now also supported on the GPU. And we have now multi-GPU rendering without NVLink. Now, let's not make a mistake. This is not multi-GPU per frame. It's a multi-GPU per shot, basically. So you can do one shot per multiple GPUs, but you're not assigning one frame for each to just have more power. So let's not confuse that part. So GPU improvement, Arnold 6.3 and 6.4. This is new. So we have a lot more support and improvement on the OSL textures. So we have some custom AUVs, IES lights as well. So wireframe shader in utility mode is also supported now. So we have improvement on some sparse textures. OSL you can trace now in AUV shaders specifically. So on the compatibility status, I wanted to share it with you where we at now with the GPU. So you might see we're very, very, very close to a final one-to-one as we promised. So we're in the cameras, we set it 7 out of 7, color managers 2 out of 2, drivers 4 out of 6, lights 9 out of 9, and so on and so forth. So shaders, we're getting close to that. So we're only missing a few, as you may see here. And shapes, you're only missing 5, but we're getting very close. I think you should stay with us and keep coming back to the Arnold GPU for your future, productions. So now talking about USD. So this is a little bit of an update we'll be doing on the USD front. I think it's a hot topic at the moment. So every single studio is migrating their pipelines from a regular pipeline to a USD-based pipeline. So one thing that is important to mention is that the Arnold USD is an open source project. Anyone can go to github.com, as you may see here the URL, and anyone can download and compile what we are doing, and even collaborate with the efforts with the project. So at the moment, what we can see here is we have a render delegate for Arnold. We have procedurals for Arnold, which I'll show a little bit now how that's working inside of the Arnold framework. We have different schemas. So schemas is how you work inside of Arnold. So how do you manipulate lights? What do you do with them? So how do you edit and conform certain things inside of Arnold? But when it comes to procedurals, the way we wanted to integrate Arnold, USD into Arnold was as simple as just going through and standing, same way we did before with the Lembic files, for example, where you could load a USD file and do all the translations and still see all the contents on the right side as you would normally do and your outliner, which is on the left side of the screen. So anything that you do with the USD procedurals and that you could do before, you can do now with USD. So you can add parameters, you can add operators, you can assign shaders, you can save looks, for example. And this is in the latest version. We also have an Arnold Hydra delegate that works instead of all plugins, including other softwares like Solarix, for example. So Hydra Delegate and Arnold is working in different packages like side effects. Houdini, as you might see now, was available, and it was presented in the Houdini 18 launch presentation, which if you're interested in to watch, you can go ahead and YouTube and just search for Houdini 18 launch presentation, and you will see on the minute 45 to 51, there's Arnold mentioned and how that works and the performance that it gives. You can see here a little bit how that works inside of Houdini. Basically, you have the same display options. Instead of Solaris, you can ignore textures, you can do your debugging, you can do your typical work inside of Solaris using Arnold. So Arnold Hydra Delegate inside of Maya, let me hit play. It also works quite nicely. This Arnold Delegate you will see in the next release of Maya, which will include the plugin of USD plugin for Maya, and basically gives you the ability to see all of the things that you would normally see in the viewport 2.0. So you will be able to see shadows, you'll be able to see ambient occlusion, lighting information, and all the relevant things. That will help you evidently to work and visualize what you're doing. Another effort that we're collaborating with is with Nvidia, and we're making Arnold available instead of Omniverse. As you may know, Omniverse is a platform designed by Nvidia, where you can collaborate with multiple people around the world dynamically inside of the same universe per se, right? The good thing about Omniverse is that it allows to have multiple GPUs working in conjunction. So it was designed specifically for that reason. So talking about what's common, what's new on the Arnold procedural framework, we have different Arnold node types. So we have the Arnold volume implicit, which is the USD extension. We have the volume implicit, which is the one inside of Arnold. So we just change some parameters to basically separate one of the other. So we have Arnold parameters and USD nodes. Basically, the subdiv iterations is applied on a USD geomesh. So talking about shaders now, we have some USD native shaders. That's the one that we normally would know. The USD preview surface, for example, prim bar, and the USD UV textures on the Arnold shaders to basically just give an info or an ID to identify that particular shader type. On the shapes, we've compatibility with all of them. So we have the geomesh, curve, point, cube, sphere, cone, cylinder, etc., etc. But the prim bars are translated as Arnold user data. So that's in order to make it a clean transition from the USD to Arnold and being able to work procedurally with Arnold nicely. So new in Arnold 6 is the ability to load a scene, an AI scene, and write an AI scene as a USD file you can, as you may know, use these plugins. So it all works. It's all exactly the same way I said before, as I mentioned, as an Alembic, and we can work with Alembic no problems. We can export the scenes USD from any application and open it in any other application. And now we'll show an example made by a fellow coworker. We have different shaders options operators that we can apply, like in import and export those shading networks. You can also render directly using USD, the kick render, sorry, so the standalone version. And yes, the procedural versus USD at the moment, it's a one-to-one mapping, so you will get exactly the same result. And you can select any frame to render to see that. So now I just want to go through some of the vision series by Sebastian Ortega, which is a fellow coworker that is basically working on the USD front for Arnold. So this is kind of a nice video. I'm just going to hit play. Just to show you a little bit how that works inside of Maya. So this is the regular mesh that is being worked inside of Maya. And you see that if you select Arnold, you will render. You already have shaders applied to it. And if you didn't know, you can now render directly in the viewport using Arnold. You can select objects. You can apply different attributes to the objects. But what we want to do here to demonstrate, we just want to export all to the USD, basically. So we're going to export these objects in a USD file directly through Arnold. And now we have the ability to check if this is true. So we've already seen it inside of Maya. We're going to launch the command prompt and we're going to send this to kick. So we're going to kick render this particular USD file. So we're going to see the result, and it's going to be exactly the same. So we are, like I said before, we have a one-to-one mapping from the USD to procedurals, and now inside of Arnold. So the good thing about this now is that now we have the USD file. We can bring that file into say, for example, 3ds Max. All we need to do is copy that URL with a file exist. And create the node, and you will see it will display the contents exactly the same way as it displays the contents inside of Maya. So you will see all of your objects listed on the right, and you will get exactly the same result, shading result, lighting result, as we exported all that information before. So we exported lighting, shading information, texturing information. And evidently, it's going to render as fast as it did inside of Maya or inside of any package. It all depends on your render settings, so obviously, but if you conserve them, it should be as fast. So now we're going to reopen the scene file, which contains a stand-in. That stand-in has a USD loaded, which is the typical kitchen from Disney. Now we're going to change the viewport draw mode to shade it so we can see the contents. So we're going to hit render. You will see it has exactly the same contents as the Disney version. So it's all same textures, all the files, all the USD information is contained here. And like I said before, we can see it on the right. But there now, because it's being loaded as a procedural, something that Arnold can understand, basically now you can apply different operations. Now, in this case, you can do even assign new shaders to objects. In this case, we're going to assign it to a shader and the table, and you see it's just a car paint. But that's not the only thing you can do. So you can also assign different other like some of the shaders to different things and then save them as looks. We're going to see that in a moment. You can do your regular work, assign presets, assign textures, etc., so on and so forth. What else can you do? You can assign different operations. So operators, for example, in this case, I think we're going to select the fridge and a few other things. So the entire group there. We're going to add an operator and we're going to hide them, basically disable. So it's a disable operators. That's something that is just happening at render time. So you're not really hiding any objects, you just disable them for the render. And you can do so for different objects, and then you can put them, as you can see, those operators are created as layers. that exist there. So you can turn them off or on. You can also use those operators. You can translate them. So you can move stuff inside, render times. And then you can see the graph just to check out on the connections to see what exactly is being done there. But the good thing is that because you have them there in the graph, you can basically enable, disable, do whatever you want. You can also save those graphs. You can save these looks. So we're going to create a new look, basically, as a layer. You can give it a name, so it's a new pass, right? So we're going to call them props. So this is a new look for the props. And we're going to assign an operator. Again, we're going to disable the other stuff. As you may see, now we're going to see the graph again, just to check on the connections. All right. So next step now is we're going to export that operator. So the operator we just created, right? We're going to export it. We're going to save it as a USD file. That's an AS file this time around. And we're going to make sure that we export all the assigned shaders. We're going to make sure that that happens. Once we do, we can basically load a new fresh scene. Because we save it as a look, we don't really have to save that particular scene. We can load the same scene again, which contain only a light and the stand-in. And if we render, we'll see we go back to the original content that we had. So next step is just all we need to do is import that operator that we exported before. As you remember, it was a USD file, so we need to make sure that we select the USD from the list. And now that's going to exist here inside of Maya, but it's not going to be connected yet. So all we need to do is just grab that look switch, what we call, right? And we're going to then select the A stand-in, and we're going to connect it directly into the operators as a new operator. And once we do, you will see immediately it will take effect in the render. So all we need to do is just then check on the switch, which will be contained on the switch on the attribute editor on the right. And we can just basically switch the index from 0 to 1. And then if we have 3 or 4 or 5 different indexes there or versions, we can just switch there and see what we're doing. So this is kind of a good advantage. So this is what you can do now with Arnold USD. Now I just want to go for a little bit just to show how this is.
Sorry, if I can interrupt, because we're running a bit out of time.
I'm done. 1 minute. I just want to show the hybrid.
Sure, just 2 minutes to wrap up, and then we also have a session for Ask Experts where you can go for more details.
Excellent. All right. Well, this is basically just want to show the new version inside of Maya. So the Maya USD version, it works exactly the same with Arnold. We have an Arnold delegate that we just selected there, and we'll see that this time around the content will show in the outliner. So that's basically what we have at the moment. So you can keep your regular work as normally as you would do. And this is it for me. I'm sorry that I did 7 more minutes. I thought it was going to be 30.
No worries. It was just we also had a delay with a presentation at the very beginning.
But that's it for me. And thank you very much, guys, for your time and your attention.